When physicists study the motions of objects, its velocity, speed, directions, and acceleration, it is termed as kinematics. But when physicists consider the forces that affect the motion of moving objects and systems, it is termed as dynamics. Newton's laws of motions are the foundation of dynamics. Sir Isaac Newton's law of motion, published in 1686, were one of his work that has made him legendary among many other scientists and thinkers. And among these scientists were Galileo also, and the Isaac Newton titled his scientific paper published in 1686 as Philosophy Naturalis Principii de Mathematica. I think is you could see you could really see it there. And Galileo, yeah, I have the picture of Galileo here, and I'm saying Newton didn't just work on the laws of motion alone. He also worked on theory of light and color, and of course, you see the one here. I can see him holding a prism, and also with other instruments. And Newton found out that the mathematics present at his age were not able to help him figure out and visualize motions of objects. So he invented a new type of mathematics, branch of mathematics called calculus. And so Galileo was instrumental in establishing observation as the absolute determinant of truth rather than logical argument. Galileo's use of the telescope was his notable achievement in demonstrating the importance of observation. He discovered moons orbiting Jupiter and made other observations that were inconsistent with certain religious dogma. For this reason, and because of the manner in which he dealt with those in authority, Galileo was punished, and he spent the final years of his life under a form of house arrest, and that was actually bad. Because others before Galileo had also made discoveries by observing the nature of the universe, and because repeated observations verified those of Galileo, uh, his work could not be suppressed or denied. After his death, his work was verified by others, and his ideas were eventually accepted by the church and scientific community. Galileo also contributed to the formation of what is now known as the Newton's first law of motion. First law of motion, um, which is also called the law of inertia. And Galileo also contributed to this law, and Newton made use of the work of his predecessor, which is Galileo, and this enabled him to develop laws of motion, discover the law of gravity, and invent calculus, and made great contributions to the theories of light and colors. Um, it was not until the advent of modern physics in the 20th century that it was discovered that Newton's laws of motion produces good approximation to motions only when objects are moving at the speed much more lesser than the speed of light, much more lesser than the speed of light and the speed of light. So Newton's law only work when you have these constraint. It only work for this, and so Newton's law actually work when you have object moving at a speed much more lesser than the speed of light, and when those objects we are talking about is actually um, larger than the size of most molecules. So when you talk about macro objects like planets, balls, moons, galaxies, and other big objects, the Newton's law will start to work. And but when you have objects such as tiny molecules, electrons, gluons, and other particles, then the laws of Newton's breaks down. And this is actually this constraint actually define the realm of classical physics. Define the realms of classical physics. Um, at the beginning of 20th century, Albert Einstein um, developed the theory of relativity, and along with many other scientists, developed the quantum theory, and this theory does not have the constraint present in the classical physics. And also, one of Albert Einstein's work that earned him Nobel Prize was the discovery of the the emission of electrons when light shines on surface of metals, which is actually called photoelectric effect. Photoelectric effect. And in the next video, we're gonna be looking at the Newton's first law of motion, and the second law and the third law of motion. See you in the next video.